welcome to the Build Test Solutions webinar series. In this installment, we are exploring the topic of the real value of airtightness testing and why it reaches much further than just compliance. This presentation will be delivered by Build Test Solutions Managing Director Luke Smith and moderated by Tanya Jane. Thank you.
Hello, everyone. So in today's webinar session, we're going to be discussing the topic of airtightness testing, and sort of, unpacking why it's so much more than just a compliance checkbox exercise. So just a quick word on who we are. Build Test Solutions, we're a business that exists to develop novel tools and techniques for measuring buildings, so empowering others to understand and establish kind of practical, actionable insights into buildings, so we can make better informed decisions. So we're equipping the likes of energy assessors, building surveyors, developers, contractors, and landlords with tools to better understand buildings. Okay, so in terms of framing of today's session, we'll spend a bit of time really getting into why airtightness is important as a topic. Why is it that we measure it full stop? And then we'll look at what's driving the market out there and explore some use cases. And then we're going to wrap up just kind of looking at embedding airtightness testing into practice. So thinking specifically about those stakeholder groups I just mentioned. So if you're an assessor or surveyor, a landlord or an installer developer, kind of what does airtightness testing mean for you? Okay, so in terms of what is airtightness testing exactly? So, what is airtightness, I should say. So what we're talking about here is eliminating all unintended air leakage into and out of a building. So, yeah, explicitly there we're talking about service penetrations, gaps and cracks in a building fabric that permits the free flow of air in either direction. Sort of, yeah, infiltration that we don't otherwise want to be there. So yeah, it can be down to the building construction, so the fundamental materials and construction methods used, and the detailing of junctions and interfaces between different building components. It can be down to workmanship, so thinking specifically about the quality of work, and again how those materials have been and junctions have been kind of executed on site as part of a retrofit or new build. And of course, air leakage, it can be as a result of general fabric degradation. So invariably a building over time will suffer from settlement, will wet and dry, expand, contract, materials kind of playing off one another and causing cracks in plasterwork or splitting of timbers. So over time, aging invariably introduces a degree of opens up air leakage pathways. And you hear a lot of sort of talk about fabric first and sort of these programs of doing insulation works on properties, insulating floors, walls, loft spaces, roof spaces. But actually, airtightness is a bit of an unsung hero in terms of that no matter how much insulation you put on a building, uncontrolled air leakage will typically account for 10 to 30% of that total heat loss from a building. So as a you can do all the insulation work you like, but if you've got air leakage paths that allow warm air to bypass that insulation, track up behind plasterboard and out of the wall plates at the top of the building, or escape through joist ends and other kind of service voids, then you've undone all of that good work. So air leakage is yeah, it's a significant contributor to overall heat loss. And of course, if we then reduce all those drafts and all of that air movement, then we're reducing heat loss, we're reducing running costs, and the associated carbon emissions with all of that. And yeah, as I just said, the word drafts, it's you're addressing that air, sort of cold air movement in a building, and so you're providing a more comfortable living environment. I would stress at this point, you often hear people say, oh, it's an old building, it's designed to be leaky. So you hear the term, it's designed to breathe. That's a bit of a misconception. From a general standpoint, what it's absolutely right to be pursuing buildings that are as airtight as they possibly can be. There's no such thing as a building that's too airtight. The whole breathability point that people make is, I think that people getting confused between air permeability and vapor permeability. So we do absolutely still want buildings to use materials that allow for the sort of passage of moisture and conducive to allowing sort of wetting and drying. But it's absolutely right that we pursue airtightness in buildings as a measure. Stealing my punchline from the next slide, really, but the key point is to ensure that delivered airtightness is complemented by an appropriate ventilation strategy. So yeah, possibly teaching you to suck eggs to an extent here, but obviously by addressing air leakage, we're delivering energy efficiency, so we're reducing heat loss, and it really is it's genuine low-hanging fruit in terms of basic draft stripping measures, sealing up certain surface penetrations, addressing failed window and door seals, sealing up loft hatches, closing off disused chimneys. We can really address leakage paths quite readily, all in the interests of energy efficiency, which in turn, second bullet point there, delivers comfort benefits. So airtight buildings are generally able to, they are better at maintaining stable temperatures. Possibly, and so they're the two most obvious ones: energy efficiency, comfort. The other one that's I think less talked about is how airtightness is generally a really good proxy on building quality. So naturally, if you're closing up leakage paths, you're then kind of closing off the opportunity for moisture-laden air from inside the building to pass into the building fabric and potentially condense on joist ends or within the cavity or behind plasterboards. You help mitigate the risk of things like interstitial condensation. But yeah, more broadly as well, it's you definitely see the direct correlation between how leaky a building is and its overall state of repair. So yeah, a really leaky building is going to be one where the windows are going to be in a poor state, rattling timber sash windows, potentially a timber suspended floor where the tongue and grooves are all split and allowing air leakage through the floor void. Potentially service penetrations. A really common one is at the back of an airing cupboard. Your flow and return pipes going up to the header tank have just been knocked through the plasterboard ceiling with a hammer. But yeah, that kind of measured air tightness more often than not directly kind of correlates with the overall state of repair of a building. And then you've got this final bullet point here on indoor air quality. So not only by making a building more airtight are we then basically regaining control over the ingress and egress of internal and external pollutants. So obviously that's important if, let's say, a property is next to a busy road. you've got a lot of external air pollutants. We don't want those to be able to freely pass into a building. And similarly, if we're building up kind of high levels of moisture, odors, and nasties within a property, we want to be able to expel that as readily as we can with a ventilation system that's effective. And so you really kind of hit this sort of the third bubble on the right there, sort of this point around ventilation strategy. Airtightness and ventilation are inextricably linked. You get this mantra: build tight, ventilate right. So as I said per the previous slide, we absolutely want to be pursuing high levels of airtightness in buildings in the interest of energy efficiency, comfort, building quality, but then making sure that we also complement that with a ventilation system that's specified correctly and works as intended. Because actually trying to put continuous mechanical extract ventilation in a very leaky building, for instance, you're going to have all sorts of issues around shortcutting and bypass, and actually the building, the fan's not able to create the negative pressure, the negative pull, the extraction that you might otherwise or that you're going to be looking for or expecting. So yeah, airtightness is really important for a whole host of reasons, but yeah, can't stress enough that intertwining of delivering airtightness and ventilation that are complementary to one another. And so actually a thread through all of these things is that airtightness testing is a really low cost and objective means of managing risk. So obviously nobody wants to be on the receiving end of poor quality workmanship or wants to be in receipt of a building. We've seen in the press recently buildings that have been insulated but perhaps not ventilated correctly. Have the air tightness levels been measured and understood so that we can manage that ventilation risks in buildings and the moisture management risk? And so low air tightness means you've got low heat loss, you've got good quality workmanship, and you've got a far better chance of delivering good performing ventilation. Okay, obviously I'll make no secret of the fact that we're a manufacturer of a device for measuring air leakage. So in our armory here at Build Test Solutions, we're a manufacturer of the Pulse equipment. So Pulse was invented at the University of Nottingham in the early 2000s. The whole Build Test Solutions business was actually set up in 2015 to commercialize the technology and bring it to market. It's a dynamic measurement of measuring air leakage. So we release a burst of air into a property, into a building, into a space, and measure the pressure response. So unlike a blower door fan where it's a pressure and hold technique, it's a steady state technique, where it's a dynamic burst of air and assess the leakage characteristics based on the signature that creates. Pulse is expressing the results directly at 4 pascals. Like I say, we're the manufacturer of the hardware. We also provide a user interface as software to complement the equipment. And the method was accepted into the building regulations in 2022, all kind of prescribed in the CIBSE TM23 protocol. And then we've got our leak checker product that is sort of a complementary diagnostics tool. So if anyone would like any further information about the kit, how it works, the pricing, any more technical information, then we're obviously on hand to help with any of that. So that's a bit of context why air tightness is important, a bit of an insight into some of the tools that are available. Thinking more specifically then about the market drivers and the kind of use cases. We've got air tightness and new build sector. So in the UK, all new build developments require an air tightness test on completion. That's both residential and non-domestic. There are some exceptions on certain non-domestic buildings. Large complex buildings, you can justify alternative approaches to building control, although they are quite punitive in terms of then what design air tightness you can declare. Testers must be suitably trained and registered with a competent person scheme. So there's two schemes that exist in the UK, the Airtightness Testing Measurement Association and Elmhurst Airtightness Testing Scheme. All testers must follow CIBSE TM23, so that's the protocol I just mentioned, which describes essentially how to prepare, measure a building, and the approach you should take in using the equipment. And the equipment described in the standard is both protocol and the pulse method. And in new build regulation, there's a maximum permitted air permeability level of 8 meters cubed per hour per meter squared at 50 pascals. And most developers today are readily building to an air permeability of 5 or better without too much drama. There was a update to the Part F of the building regulations made in 2010, which made an explicit link between air tightness and ventilation system choice. So within Part F, okay, it's not explicitly requiring air tightness testing. That's separate and in Part L, but Part F has these two clearly defined definitions. One for a highly airtight dwelling, which is where the designed air permeability is expected to be 5 or less, or the as-built measured air permeability 3 or less. Or there's the definition of a less airtight dwelling, which is assumed to have an as-built air permeability of 3 or more. So you've got these these two characterizations within Part F, and that is actually used as a set of guidelines to inform what ventilation system is appropriate. So in the new build with 100% requirement for testing, the real opportunity is essentially to look at efficiencies and supporting developers with their overall kind of pass rates and the ratio to which passing first time. But to really, I think, hammer home this link to the ventilation. So developers are they are really genuinely walking this tightrope, trying to actively manage the balance between the air tightness they're delivering and the ventilation risk that then carries, or the ventilation system that they're then installing. I think it's fair to say historically we've delivered mediocre levels of air tightness in new build homes and just gone with intermittent extracts and some flimsy trickle vents that may or may not work very well. And really, as we push on with air tightness levels, actually that kind of intermittent extract ventilation strategy no longer cuts it. So we're straddling that tipping point of it's right that we pursue greater levels of air tightness. It's not overly difficult to improve on an air permeability level of 5 or so, but it needs to make sure that it's complemented with a suitable mechanical extract ventilation system that is working as it should. Obviously, if it's not working as it should, and you do still have the air tightness, then we're storing up all sorts of trouble for ourselves in terms of condensation and mold risk problems in the future. And it's quite interesting to observe on new build, more ambitious air tightness targets tend to drive a culture of intermediate testing. So testing at sort of test the primary air barrier before then final fixes and final finishes are applied. And I think as you push on with air tightness, there is naturally this more kind of conscious consideration of ventilation. So it snowballs and it drives just an overall better recognition of these things. So yeah, new build, quite an interesting space, and still lots to be learning and going at. Moving on to retrofit then, and the role of air tightness required and the procedure that needs to be followed. So CIBSE TM23 is expected to be followed if you're doing testing in accordance with PAS 2035 or using air tightness tests in EPCs. But then the market pool here is a bit more nuanced, because you don't have Part L simply mandating that all existing homes are air tightness tested. Instead, we've got PAS 2035, the current 2023 version, requiring that wherever you're doing any energy efficiency improvements, any fabric upgrades or changes or alterations of any kind, that we've got to put in place for every property an air leakage testing strategy. So you've got the relevant clauses cited there. And so really justifying in that strategy your approach to airtightness in the round, how are you delivering airtightness on these projects, but also then how are you approaching airtightness testing? What sampling are you using? Justify that sample. What are the risks that you're dealing with? And how are you managing those? Very complementary to that PAS 2035 airtightness strategy requirement is Part F, Section 3. So this is the whole section within Part F ventilation guidance on existing buildings. Now, the requirements here are triggered whenever you replace or modify any existing ventilation in the property, or if you're installing any energy efficiency measures. So we've got section 3.7, which references guidance around using airtightness testing and expert advice as a means of assessing ventilation suitability. So there's a clearly sort of defined role for air permeability testing there. And you've got section 4.9 explicitly requiring that all ventilation systems that are installed in existing homes and new build have airflow rate testing carried out. Kind of further supporting those two areas, I guess, you've also got, since June this year, RDSAP 10 now permits the input of measured air tightness into EPCs. So if you might have otherwise thought, let's have a strategy that does the bare minimum to just satisfy PAS, really there's an underlying value there on the client side, the housing association, the landlord, the property owner, that with an airtightness test that can be inputted into the energy calculation and better reflect more accurately the performance of the property in question. So we know from a lot of our data that generally existing buildings are more airtight than the default values used in EPCs. And so in most cases, in using a measured value in place of the default is going to be worth between 1 to 3 SAT points gained. So for the cost of a SAT point, cost of a test, the price per SAT point gain is hard to ignore. Obviously, full SAP and SBAM also permit the input of airtightness tests into those calculations. In a very similar vein, you've got airtightness tests can also be inputted into the MCS 12831 heat loss calculations used for heat pump sizing. So again, it has a very similar effect. You're overriding otherwise conservative defaults with measured parameters that more accurately reflect the true performance of the property, and that's tending to reduce your overall calculated heat loss number and help you more appropriately size the kit. It could be the difference between a job being viable or not. It could be the difference between thinking you have to replace all your radiators or not. So yeah, really quite impactful there as well. And then you've got also within PAS 2035, there's Annex C, which is essentially its own kind of mini Part F, requiring that ventilation is duly considered on all projects. And the Installation Assurance Authority operates a scheme called background ventilation testing. And this is, again, it's a risk-based approach of assessing pre and post works levels of infiltration and overall ventilation adequacy. And so sticking with the retrofit theme then, most pulse tests are uploaded to a central database. I think the last publication I've seen on the air tightness characteristics of existing homes was one published by the BRE back in 2000, and it was based on a sample of, I believe, 470 or so dwellings. So that provides some great insight, but it is based on a very small sample. So with 150,000 tests and counting or so on the Pulse database. So it's a really significant step up in terms of a sample of existing UK buildings. And what we're observing in this data set is a mean air permeability of 8.3 meter cube per meter square per hour at 50 pascals. But then what's quite insightful is also the standard deviation on that sample, and what we term as a statistical reference here, the coefficient of variation. So at 43%, which is basically very high, what it's saying is that the spread is quite wide, and so as much as we can state this mean value of 8.3, the reality is what you could be dealing with is equally just as readily a property that's an air permeability of 2, through to, and it could be still through to anything up to 20 or more. So yeah, really wide distribution on the sample, which is really quite interesting, I think. So yeah, just kind of reflecting, thinking what that means for what I was just saying before about RDSAP and EPCs. So we've done some simulations on this, and we think more than 75% of EPCs would improve the rating with a measurement overriding the default value. So you can see here that there's the overall distribution, the mean of 8.3, and the typical default RDSAP values will land anywhere between 10 and 15. So yeah, more off the inputting a measured value, you're going to improve on that. And then very similar thing for heat pump sizing. Here you've got the same distribution, the mean of 8.3, and the defaults in the CIBSE domestic heating design guide that the MCS 12831 calculator references, again, assumed air permeability to be anywhere in the order of 10 out to 20 or more air permeability. So yeah, it's not all that surprising when the default values are that conservative, and this, in fairness to them, they need to be, because buildings can be that leaky, but it's that classic adage, you can't manage what you don't measure, and actually more often than not, when you do measure the existing property without even making any improvements or trying to address some of that low-hanging fruit, is actually lower than you might have otherwise thought. Okay, so then you might think, well, can we just use that database to improve the default values and save everyone the bother of doing any measurements at all? It is a reasonable sample of 150,000 or so properties. But here I just thought I'd show you, this is just looking at the distribution of EPC C only properties. So just that band C. This is obviously a broad church in terms of the built form and age, but yeah, so just band C property. And again, you can see really wide, quite flat distribution. Mean air permeability here of 8.6 for what it's worth. And then here, looking just at solid wall semi-detached homes, and the mean is 8.9, but for that very specific construction, that very specific typology, again, you could be just as readily a air permeability of 2 or 3 out to an air permeability of 20 or so. So just because the mean value is there, and just because yeah, there is that slight peak on the distribution, actually it's really quite varied. And I think the message here really is that it's really tempting to take archetypes and you sort of really streamline your sampling, but actually no two properties are the same, and there's hugely variable air tightness out there. And just to really kind of hammer that message home, two visually similar properties here. Terrace, two up, two down. These are 2 doors down from one another. One is measuring an air permeability of 4.36 at 50 pascals. The other 10.9, so more than double the air leakage rate there. And yeah, to look at them, or certainly to look at them as a desktop exercise, they're very similar. But actually, unsurprisingly, these properties have stood for over over 100 years, and they will have aged differently. They've been in receipt of upgrades at different points in time, of differing levels of quality. Different defects have occurred over time, and as much as they're the same footprint, same primary construction, they're measuring as very, very different levels of air permeability. And you would take quite different action with those test results on these two properties. You would naturally want to understand why the one on the right there is so leaky. And there's invariably going to be some quick fixes to be done there, because otherwise your ventilation system's just going to be not at all effective, pulling on a fabric that leaks like a sieve. Okay, so just final few slides then, and we'll get into a bit of Q&A. So what does sort of air tightness testing mean if you're a surveyor or an assessor? So clearly you're going to need to be thinking about the training and equipment that you need. So regardless of the market, whether you're going into new build or retrofit, you're going to have to be qualified and competent. You're going to have to get yourself on a training course. You're going to have to think about what services you want to provide exactly, and then what kit you need to obviously provide that said service. You could absolutely just get into this space with a view that regulation is telling people they need to test. I'm just going to be an out and out air tightness tester and offer compliance testing, new build and retrofit. I'm just going to offer test results, end of, and just try and really drive kind of utilization of your kit to test at maximum kind of volumes and efficiencies. But I do also think there's really great opportunities out there to be a bit of a critical friend across air tightness and ventilation. So help people undertake more than just the test, so sort of property risk assessments, links nicely with the kind of impending requirements around Howard's Law, help landlords and contractors, installers and the like develop their testing strategies, and the associated action plans. Okay, you told me my properties are leaky, what should I do about it? Really kind of you can go so much more than just the test. I also like the kind of the term super assessor. So again, lots of people have already kind of cottoned onto this, but there's a lot to be said for being as efficient as we can be in, once you gain access to a property, you've gone to the trouble of driving there, getting through the front door, you want to be able to offer as many services as you can to the client. So retrofit assessment, an EPC, an air tightness test, perhaps a background ventilation test, perhaps some ventilation, flow rate testing, perhaps some condition reporting, perhaps some underlying kind of supporting advice reports. Again, I'm not just telling you you've got these problems, here are the solutions, here's what you might be able to do about it. And look at how you bundle those things, not just kind of stacking the cost of one on top of the other on top of the other. You can really start to get quite a streamlined workflow around these things in buildings. And a similar sort of vein, really go beyond the measurement. So use the measurement results to plug into EPCs, to plug into energy performance reports under the energy company obligation, plug into heat loss calculations for the benefit of heat pump installers and the like. And I think this is kind of a classic for anyone in business, really, but to have your USP and specialism, and where you can try and focus on one primary market segment and do that very well, rather than being perhaps a jack of all trades. So then, if you're a landlord or an owner of multiple properties, perhaps, again, shouldn't really be thinking of this as just a pain in the backside compliance exercise. There is so much more value to unlock from the tests. You can input them into your EPCs, you can input them into your stock condition reports, you can input them into your wider kind of energy efficiency planning and investment decision making. You can use the tests as a sort of key component part of your mold and condensation kind of strategy and your response to complaints and addressing kind of the root cause of those issues. You can link it all up with your ventilation investment plans and your overall ventilation strategies for buildings, and of course your heat loss calculations. Yeah, I can't stress this enough. Sample test at your peril. No two buildings are ever the same. It's really tempting to just say, well, that's a street of terrace properties. They'll all be there or thereabouts. Let's just test one of them. I can guarantee that whole street will be hugely variable and you'll take different action on each and every one. I've seen a lot with procurement, so be really, really clear if you're out there asking for airtightness testing, prescribe the protocol you want to be followed, the expected building preparation, the prescribe that you want a set tester competency, so qualified to level 1, member of a competent person scheme. At the end of the day, you get what you pay for, and you need to be really prescriptive with this stuff. And again, that's an area we can help you with if it's of interest. And really kind of not just receive air tightness tests and stick them in a folder somewhere on your hard drive and forget about them. Like, really take the measurements, try and feed them into your asset registers, try and feed them into your models that act on those numbers and learn from it. Like, really try and establish these feedback loops. What works well, not so well, inform future projects with the measurements. And only by doing airtightness testing at reasonable scale, pre and post, painting a picture of what measures were installed, what effect did it have, do we stand any chance of any kind of meaningful continuous improvement. Lastly, then, just for installers, developers, again, it's beyond compliance. You've got your EPC and energy performance reporting uplifts. You've got it feeding into your ventilation strategy. It's allowing you to more accurately size heat pumps. It's all about risk management, providing a really clear, objective evidence trail. Deliver solutions right first time. Let's not wait a year and then realize there's a huge condensation mold issue. Actually, if we're measuring on completion, signing off, making sure the ventilation is working as intended alongside the air tightness, everyone's a winner. Consider air tightness testing either as an in-house activity that your own teams skill up and have the equipment and deliver, or work with partners. So that's obviously going to be influenced by the nature of your work and your overall business model. We host a directory on the Build Test Solutions website of people with Pulse kit that can service your air tightness testing needs. So that's always worth a look. And then, generally use the results. Again, it's not just a compliance tick box, it's to be better at making more informed decisions. So identify and address root causes of mold and condensation. Carry out a test, take action on that test, rather than just let's wash the walls and paint them and then deal with the issue again in 6 months' time. And make much better informed investment decisions, target spend where it's going to have the most impact. So hopefully a bit of time left for Q&A there. So what on the face of it is a simple test. There's an awful lot of value behind the air tightness test number. No two buildings are the same. Air tightness testing is in essence all about risk management, gaining more accurate understanding of your building and their ventilation needs. Our next webinar, just quickly, is we'll be looking at assessing thermal performance in heritage buildings, the challenges and solutions. There's a QR code there to register for that one on the 23rd of October. We've got our own conference coming up on the 9th of October at Loughborough University. We're calling it the world's #1 BPE Fest. So lots of equipment on show, demos, speakers from our own team here at BTS, but also we've got a member of the team from DevNes, as well as academics and other industry partners. So QR code there for that one. And then I touched on training and competency a few times. We've got our own level 1 air tightness testing training course. The first session is running 21st to the 23rd of October. So it's 2 days worth of online content and then 1 day practical at the BTS office. So if you're looking to expand your team or get people into air tightness testing, then the training course is always a good place to start. Cool. I'll stop there then, and hopefully we've got a few questions we can jump into.
Excellent. Thank you so much, Luke. Yes, we have had a good raft of questions come in. So I have got them all in chronological order. I will start at the top and we'll see how far we go before we run out of time. So the first question came in quite early on from Richard. If retrofit coordinators and architects on retrofit are providing DHMEV, is this incorrect for leaky Victorian homes?
So no, it's far obviously decentralized MEV continuous running fans are going to be far more effective as a solution than any kind of what might have been previous kind of installed intermittent extraction, or dare I say it, no wet room extraction at all. I think my point on the leakiness was just what we do have to be mindful of is that risk of shortcutting. So if you've got your wastewater pipe with sort of clear gaping holes and air leakage paths around various kind of service penetrations in the bathroom, that fan continually pulling might not be, yes, it's providing extraction on the bathroom, but it could just be looping in that one room and not pulling on the rest of the property very effectively. So yeah, continuous running DMEV, definitely a step in the right direction, but it doesn't render it completely ineffective, but it's going to be a far more efficient and effective solution if air tightness has also been looked at in tandem.
Great, thank you. Our next question came in from Alex. Is there a benefit to get a building below any other level than 3 air changes? I would have thought that any improvement to air tightness would be useful. Does it just mean it can't be recognised officially unless it beats that measurable 3 air changes or less?
I think so there is invariably a law of diminishing returns, but generally, yeah, any improvement in air tightness is a good one, and talk about the associated drafts and discomfort, and so yeah, we should. There's no reason to stop at 3. I think what's being referred to here is that within SAP and Part L on particularly on new build, if you're going below 3, an air permeability of 3, and but not upgrading the ventilation system beyond intermittent extract, then the benefit that you can see is capped. So just to try and encourage people to say, look, if you're dipping below an air permeability of 3, if you want it recognised, you need to show us that there's a suitable sort of complementary ventilation system in place. Just trying to really help it make it sort of drive that enforcement between Part L and Part F.
And in addition to that, Alex also went on to ask, does the dynamic system of pulse help you identify where the leaks in the building might be? With a blower door in a house under pressure, a smoke wand can help find the culprit.
Absolutely, yeah. And yeah, I'm really not out to kind of necessarily play the two methods off one another. Each has their benefits and drawbacks. A drawback of pulse is that it is just releasing that immediate burst of air and cannot be used for leakage diagnostics. It's not sustaining the pressurization to go around and find leakage paths, which is why we developed the leak checker fan as a complementary tool. What I would say though is generally diagnostics with a blower door fan tends to be done a bit late in the day, as like your compliance test at the end of a process. And really, we don't really want to be trying to address air leakage at such a late stage with not so robust solutions like mastic and expanding foam and what have you. So I think as a more general rule, we want to be encouraging a culture of intermediate testing, or we try and pitch the leak checker tool at site teams and contractors so that they can test as you build or retrofit, so that there are no surprises when it comes to the compliance test at the end. But yeah, it's absolutely true to say with a blower door fan, you can hold pressurization and go around and trace leakage paths fairly effectively with a smoke pen or a thermal imaging camera. That's correct.
Brilliant, thank you, Luke. And next question is from Alan. Is it correct that every new build home has to have an air test? Is it not correct that only a sample of each house type should?
It used to be sample based, but the regulations have gradually cranked up on the strictness, and it's now it has been for some time actually. It is a requirement to test 100% of new builds, no matter how big the scheme, how many plots. It's every single one.
And Mohammed has asked, is an airtightness test mandatory for retrofit projects for category B? And could you share any airtightness strategy samples?
So I believe what's being referred to here in terms of category A, B, and C is what's referred to as your risk categories in Part F of the building regulations. There is no strict explicit it's mandated that because you're at risk category B, you have to have an airtightness test. But what that is highlighting is that to be category B or C, you're invariably doing a bunch of interventions that are likely to significantly improve the airtightness and have a detrimental impact on ventilation and air quality. So it's trying to flag that you've got a problem here that wants to be managed. Obviously, it's every individual's discretion kind of how we want to manage that risk, but I would argue it is very wise to do a test and understand exactly what you're dealing with. It might, for instance, say that you're category B, but actually the property's quite leaky, because to get to category B, you would otherwise just be using quite a simplified major minor table. And I've forgotten the rest of the question.
Can we share an airtightness strategy sample at all?
Yeah, so in essence, your strategies boil down to intermittent extract with background ventilators, and those background ventilators having to present a certain free open area. Swapping that intermittent extract fan out for a DMEV system, a continuous running decentralized fan system, also still pulling through on background ventilators, through to loft mounted centralized mechanical extract systems that might otherwise, it might be more practical to kind of duct to different wet rooms from a roof space. But being a roof mounted device, they tend to be able to deliver much better overall extract rates, bigger fans, more powerful fans, and then through to MVHR, mechanical ventilation heat recovery, which deals with both the supply and extract. And so then when you're into that kind of territory, you no longer need the background ventilators. But you're right to highlight it as an area where I think more guidance is needed for installers and the supply chain as to what ventilation systems and strategies exist that work in relation to given levels of airtightness. I think that there is a gap there, and that's maybe something we could look at as BTS perhaps.
Brilliant, thank you, Luke. We have a question from Elliot. Do you have details on the level of variation you might find between doing a pulse test and a blower door test on the same property, such as a percentage deviation average?
Mm-hmm. So we've done an awful lot of work on this, comparing the two methods in controlled environments through to large kind of field trials across lots of different types of homes. As a general rule, pulse repeatability will be within plus minus 5%. Just sitting there doing repeat tests with pulse on a given property. Blower door repeatability is also generally pretty good, plus minus 5%. And so the combined uncertainty, we as BTS would be pretty alarmed if we're seeing differences between the blower door and pulse of 10% or more. So within that 10%, pretty comfortable. It's within kind of the expected levels of tolerance on each method. More than 10%, and you're potentially into the realms of, or maybe blower door depending on whether you're pressurizing or depressurizing, you could be affecting the fabric in a slightly different way to pulse just releasing a low pressure, or maybe the front door could be part of the equation where you've had to compromise the front door for the blower door fan, whereas pulse includes it in the test. And so sometimes like a really poor performing front door that's not been in the equation for the blower door could be the explanation for the difference. But yeah, generally within 10%, short answer.
Thank you. Question from Dave. Have you done a lot of same property, different day testing to be certain there is a minimal variation in same property test results?
Yes, we've done lots of that. And there are lots of technical reports on our website that we openly share. And I appreciate some of them a bit heavy from a technical standpoint, but yeah, we have done that, and again, happy with the overall repeatability of pulse being within those bounds of kind of plus minus 5%.
And I have a question from Amy. Please, can you explain the diagnostic kit to go with the air test?
Yeah, so pulse kit is a standalone system, air receiver, compressor, controller, self-contained bit of kit. We have a separate product called Leak Checker, which is, like I said, on one hand, we try and couch it towards installers, site teams, for them to be using themselves on site, but as a sort of consultancy tool or a tool that can be complementary to Pulse. Yeah, some testers do carry that as well. And yeah, Leak Checker essentially is it's a mini blower door. It's a mini fan designed to be window mounted. Quite a simple mounting mechanism, telescopic pole wedged in a window frame, bulldog clips mounting kind of a nylon sheet in the window, fan poking through the elasticated hole. It does, and so its primary purpose is that diagnostic thing. It's depressurizing the building to create a pressure difference that you can then feel air leaks with the back of your hand, track air leaks with a thermal imaging camera or smoke. But it does include a differential pressure sensor, so we know the fan speed, we know the airflow through the fan, as well as then the pressure difference between inside and out. So it can also provide a bit of a guide on the level of air permeability that you're currently delivering. So again, there should from that then be no surprises when it comes to the compliance test at the end.
Brilliant, thank you. And a question from Neil. How well suited is pulse testing to larger scale buildings rather than dwellings?
Good question. I do, sort of happy to sort of openly admit there's a practical limitation that you soon bump up against. So yeah, pulse, the capacity of the system can be extended by daisy chaining additional air receivers. The overall capacity is then determined, it's a function of both the size and the leakiness of the building. So if you had a very large but airtight or non-domestic building, then you could be within the sort of practical kind of limits of I don't know, you might deem it sort of impractical to have much more than 5 or 6 air receivers perhaps. But then if that larger building also starts to get quite leaky, you'd start to stretch beyond the 5 or 6 air receivers. And I'm prepared to sit here and admit that yeah, it starts to become sort of a not as particularly economical kind of to have tens and tens of air receivers all linked up across a building. So we host a sizing guide on our website under the help section. There's a pulse section and pulse sizing guide, and there you can input building volume and leakiness and have a play with kind of the different thresholds that different kits can deliver against.
Fantastic, thank you. And I think that the next question that was in from Mark has probably also just been answered. Mark, you were just asking whether the equipment will work in a large scale corporate building setting. Pretty much the answer above. Yeah. The next one then is, how do you detect all the locations of air leakage if using the pulse method?
your that question's also come up already around the diagnostics capability of Pulse. So it's not going to pinpoint exactly where your leaks are. It's providing a measure of the overall leakiness of the fabric. I would say that in itself is actually very instructive. So just to say, yeah, we've measured this home, we expected it to be an air permeability of 5, it's actually an air permeability of 10. Even just to react on that and do a walk around survey of the building, there a lot of leakage paths are quite common across buildings in terms of your loft hatch, your common service penetrations, your window seals, how well the windows seat the doors, and so yeah, the first port of call in my opinion would be that you do sort of an observational assessment post test, but then if you did want to get into more in-depth diagnostics, tracking leakage paths, then you're into rigging the leak checker fan.
Brilliant, thank you. And I think we've got time for maybe one more question from Michael. Does BTS offer the required training for Ventiflow?
It's a pretty straightforward piece of kit to operate. It's supplied with manuals and support. We don't currently offer training in its use, but it's something we are looking at, but going beyond just the operation of the kit and also kind of framing the wider context around actually that's kind of what we were talking about earlier, around ventilation systems and strategies, and so yeah, we're looking at a broader ventilation training course. It would include then training on how to operate the Ventiflow and Flow Finder equipment that we sell, as well as our mold risk product, which was the subject of the previous webinar.
Great, thank you. And I think I've got time to just squeeze one more in. What setup is recommended for a heat pump installer? What differences are there between your solutions and all the other solutions out there?
So you've essentially got two main options technology-wise, either a blower door fan or the pulse equipment. The pricing and all the details on Pulse is available on our website. The main question would be, what's the typical size of building that you're tending to buy heat pumps for? And that will dictate whether you're into kind of a single air receiver kit or a sort of increasing the capacity and having an additional air receiver. And yeah, then sort of complementing that with the training, and away you go.
Fantastic, thank you very much. So that brings us neatly through to 1 o'clock. We finished on the nose. Well done, Luke. Thank you everybody who's joined us today. We will of course be sending out the content for you over the next few days once we've had a chance to download it and get it all ready for you. Thank you so much, and we will hopefully see you at the next one. Thank you for joining us for today's webinar on airtightness testing. Our next webinar will focus on the challenges and solutions around assessing the thermal performance of heritage buildings. We hope to see you there.